we have to understand two things. First thing, that exponential function is always an increasing function. But if I will try to change exponential function into the form of e to the power minus x, what are the changes that we can see? Second thing, what is the value of gx that we'll find, where we are taking the value of x one time as negative and one time as positive. So both are the values that we are taking. Then what are the changes that we can see in the function that is given as 1 upon 1 minus e to the power minus x? For that, we have to find the value of increase, whether this function is an increasing function. This is the thing that we have to find. And next thing that we have to find, that whether this function is an 1 function or not. Two things are there. For that, firstly, we have to find the value of gx. So the value of gx, that we can write it here, that is equal to gx is equal to f of minus of x minus of f of x. I can write it like this. And this f of minus of x can be written as 1 upon 1 minus e to the power x, because minus will become positive. Now here you will write the same thing as 1 minus e to the power minus of x. This value will become 1 upon 1 minus e to the power x. If I will take here the LCM, I will write as e to the power x minus of 1, and this value will become e to the power x. So we can write the same thing as 1 minus e to the power x. If I will take minus common, this value will become positive e to the power x 1 minus e to the power x. If I will take the LCM, you will get the value as 1 minus e to the power x 1 plus e to the power x. Now, second thing, whenever we have to find the value of whether the function is an increasing function or decreasing function, you have to find the value of g dash x. So the value of g dash x can be written as dy by dx of 1 plus e to the power x upon 1 minus e to the power minus of x. Let's differentiate the numerator first, and you will write it as e to the power x, and here you will write 1 minus e to the power x. Now let's differentiate the denominator. You will write it as 1 minus e to the power x to the whole square, and this value, okay, because we are taking the negative value, so we can write it as like this. Now everything will become, because we will take 1 plus e to the power x as it is, and if I am differentiating the denominator, it will become 1 minus e to the power x will become minus of e to the power x, which means that if I will take the LCM, you will get the value as 1 minus e to the power x to the whole square. Here you will write it as e to the power x 1 minus e to the power x, minus minus will become plus, and this value will become 1 plus e to the power x. If I will take e to the power x common from here, you will get the value as 1 minus e to the power x plus 1 plus e to the power x. I will write it like this, and the denominator will be as it is, 1 minus e to the power x to the whole square. This value can cancel this value, and you will get the value as 2 times of e to the power x upon 1 minus e to the power x to the whole square. E to the power x will always be a positive value. This is the important concept that we have to learn from this question. E to the power x will always be a positive value. So e to the power x will always be a positive value. Okay, whether we are taking negative one or positive one, this value will always be a positive. Next one, if I can write as 1 minus e to the power x, this value is negative. Okay, if I am taking the value of x, that should be greater than 1. If I am taking the value of x greater than 1, this value will be negative. If I am saying x value is in between, like if I am taking a value of x in negative sense, then we can say this value will become positive, because root of 2.73, if I'm taking it into the form of fraction, this value will become this value will become positive, and if I'm taking x is greater than 0, this value will become negative. But here the important thing is, here it is given that square, which means that this value will always be positive, which means that I can write the value as e to the power x 1 minus e to the power x to the whole square, which is always greater than 0. Always greater than 0. Important thing, that we have to learn from this question. That is e to the power x upon b e to 1 minus e to the power x to the whole square will always be greater than 0. Done. This is the important concept, which means that we can write the value of g dash x will always be greater than 0. If I am saying g dash x is greater than 0, so we have to say it is increasing function. If any function is an increasing function or decreasing function, so I will get a graph something like this, which means that for all values of x, we will get a particular value of y. And that's how we can say this function will turns out to be one function. So there are two things that we are understanding from one question, which will help you to solve so many questions in terms of like this. Hope you have understood this question. If you have understood everything, you can like this video and share it with your friends so that they can understand how to go through with the question and how to take some important things from these questions. These kind of questions will help you to solve JEE papers in a more efficient way, and that will help me also that I have teach you something in terms of like that. Okay, if you like my video, you can share this video and you can subscribe to my channel. Thank you.